Somebody call 911.
Have you ever been scrambling to get yourself out of a burning building and stop to think, right now would be a good time for a dance party? Yeah, that happens to me all the time too. So when I was browsing eBay the other day and found someone selling a fire alarm trigger, I was intrigued. I immediately bought one with the intent to make this a reality. I chose to use the ESP8266 microcontroller for this project because it's cheap and it has built-in Wi-Fi functionality. The Wi-Fi was a must because I didn't want to have to route a bunch of wires out of the fire alarm. I removed the original PCB from the alarm so I could fit the ESP and a battery inside. Since I didn't have any battery holders that were slim enough to fit in the alarm housing, I designed and 3D printed one myself. The battery goes through a lithium battery protection module right here, and the output of that goes through this buck boost converter that will provide a steady 3.3 volts to the microcontroller even if the battery voltage drops. Finally, I wired in this push button to use for resetting the lights and music when the party is over. The fire alarm mechanism itself is basically a glorified toggle switch. When you pull the handle, it flips this switch, which turns on the ESP. In fact, that mechanism was actually broken when it arrived, but I was able to fix it using a pretty janky combination of paper clips, rubber bands, and epoxy. And you'd never know that I had to repair it, unless you look at the bottom of it. But when it's mounted on the wall, you don't really see that part. But anyways, as soon as the ESP8266 turns on, it just sends a wireless signal to the lights and the speakers to turn on. Next, I started work on the lighting. I bought one of these cheap disco lights online. It came with its own control circuit out of the box, and I was originally planning on just using another ESP to toggle that circuit on and off. But look what I was greeted with when I opened it up. Yes, those tiny wires there are 220 volts coming straight from the plug. So yeah, I ditched that death trap and made an entirely custom control board powered by another ESP8266. In particular, I used an off-the-shelf DC power brick that I had laying around, so that I didn't have to work with mains voltage at all. The power brick outputs 5 volts, but the ESP8266 needs 3.3 volts. So I got a voltage regulator that will drop it down. The disco ball just consists of 3 LEDs on a disc that gets spun around by a small motor, and the plastic dome on top scatters the light. Because the pins on the ESP can't supply enough current to power the motor or LEDs directly, I used a few transistors to drive them instead. I soldered it all together on a piece of perf board and glued everything back into the plastic housing. I plugged the power brick into an outlet behind the couch and used cable ties to route the wire up the wall to the disco ball, which I mounted with a wad of black duct tape. I made sure to be extra messy during this step so that the tape and zigzagging wires could become a permanent eyesore on the side of my wall. Next, I wrote up a quick program to test everything out and make sure it was working so far. On the fire alarm side, we simply have to broadcast a message wirelessly to the ESP8266 inside the disco ball. As soon as the disco ball receives the signal, it should start flashing and spinning the LEDs around. I uploaded the code and could now control the disco ball remotely, and pulling the fire alarm was able to trigger it flawlessly.
A great success!
For music playback, I used one of these Bluetooth speaker modules that you can get for just a couple of bucks online. You can connect your phone to it just like any other Bluetooth speaker and control things like volume and playing or pausing the music via a couple of digital input pins. The only function we need is to unpause the music on demand. So I got yet another ESP8266 and hooked it up to the play-pause pin of the module according to its datasheet and soldered them together on perf board. I got these speakers from some old electronics that were being thrown out and connected them to the left and right channels of the Bluetooth module through 2 cheap amplifier boards. These MOSFETs over here allow us to power off the amplifiers while they aren't actively playing anything. The amplifiers need a fair bit of power, so I used this 18-volt power supply. Again, the ESP runs on a much lower voltage, so I stepped it down using this adjustable buck converter. I wired everything up and glued the boards next to each other on a small piece of wood. I fully intend to build a nicer looking enclosure for this, but I'll do that, later. Anyways, now we essentially have a homemade Bluetooth speaker that can be controlled remotely in order to play and pause music via the fire alarm. The last thing we need is a way to automatically turn off the lights in the room when we pull the fire alarm. Luckily, we can do this easily using a couple of these smart Wi-Fi relays. I chose this kind specifically because they actually have an ESP8266 inside already, and we can reprogram them with our own code to interact with the rest of the fire alarm system. Using a USB to serial converter like this one, I connected a relay up to my computer and was able to flash a program to it just like you would any other ESP8266. I repeated this process for the second one, then carefully wired them in series to both lights in the room. The last thing to do was to curate a playlist of fire-related songs and write up the final piece of code to control it all from the fire alarm. And with that, the project was complete. Now I can finally sleep at night knowing that if there's ever a fire, at least I'll be able to go down in style.